So this is the 49th video on Newton's laws of motion. This is in continuation of the 48th video. Okay. So in this problem, I'll take up numerical on Newton's laws of motion using the constraint theory, combined equation of motion, and pseudo force concept. Okay. First, let's draw the diagram of the situation. This is a smooth horizontal surface. This is a fixed vertical wall. This is also a smooth horizontal surface. A block of mass m is placed here. There is a pulley here. String is attached to this pulley. Okay. There is a string attached to block of mass m, and this passes over a smooth pulley. Then here there is a wedge, and here there is a block of mass 2m. Okay, fine. And this angle is 60-degree angle. 60-degree angle. Okay. And this is a wedge of mass 4m. So there is no here. This is a fixed horizontal surface. This is a fixed vertical wall. This is also a smooth horizontal surface. These are two smooth pulleys. This is the string. String is massless, inextensible. There is no friction anywhere. This is also inclined surface of the wedge, no friction. This is a block of mass 2m which can slide along this inclined surface of the wedge. This can move horizontally. Okay. The question is, when the system is released from rest, find the tension developed in the string. Okay. Find tension T in the string when system is released from rest. Okay. This is the question. First of all, the string is massless and there is no friction between string and the pulley. So tension at all points of the string is same, equal to T, say. Fine. Now I show the accelerations of the blocks arbitrarily. Suppose the acceleration of this block of mass m is a with respect to ground. Suppose the wedge moves leftward at an acceleration b with respect to ground. And suppose that 2m moves down the incline at acceleration c with respect to wedge. So this is wedge W, W for wedge. This is the block P1. This is the block P2. A is the acceleration of block of P2 with respect to ground. B is the acceleration of wedge with respect to ground. And C is the acceleration of mass block of mass 2m with respect to wedge. Okay, C is with respect to wedge. A and B are with respect to ground. Okay. First, what I do, I draw the free body of this block of mass m with respect to ground frame. All right. So free body will be something like this. These are the only real forces acting on the block. Now I write down the Newton's second law equation for this block in rightward direction with respect to ground. So that will simply be T equal to ma. That is the first equation. T equal to ma is the first equation. Okay. Now what I do, I draw the free body of this block with respect to wedge frame. Okay. So I draw the free body. Okay. Mg, tension T. Let's call this N1. Let's call this N2. Okay. Now this wedge is an accelerating frame with respect to ground. So this is translating NIRF. As seen from wedge, a pseudo force will act on this block. Okay. So that will be 2 MB. On the theory of pseudo force, that will be equal to 2 MB. Alright, fine. So 2 mg and 2 T and 2 MB. Now I write down the Newton's law equation of this block in downward direction with respect to wedge. So from this diagram we see it is 2 mg sine 60 degree root 3 by 2 plus 2 mb cos 60 degree. Cos 60 degree is 1 by 2 minus T is equal to 2 mc. This is simplified still further simplified. 2m goes away. 2m goes away. So this becomes g root 3 plus b upon 2. No, doesn't go away, sorry. I just cancelled it. Okay. 2 doesn't cancel, it remains. This t also, no? 2 doesn't cancel out, sorry. Okay. By mistake I cancelled it, I've rectified it, okay? So this becomes mg root 3 plus mb minus t 2mc. This is the second equation, okay? Fine. Alright. First equation is that t equal to ma. This is the second equation. I cancelled 2 wrongly, I rectified that, okay? Then it becomes mg root 3 plus mb minus t is equal to 2mc. Okay. Now what I do, I write down the combined equation of motion of m and 2m, 4m and 2m with respect to ground, same leftward direction. Okay. For that what I do, I draw the free body of 4m and 2m separately with respect to ground. Okay. So I draw the free body of 2m with respect to ground. See, here I draw the free body of this with respect to wedge. But here I will draw the free body of 2m with respect to ground. Because I have discussed it in the previous video also, that whenever we write combined equation, it is written with respect to ground frame. So only real forces act on it. So, but this FBD was with respect to wedge, that is non-inertial frame. But when you draw the free body when we write down the combined equation, we have to draw the free body with respect to ground, because we are applying combined equation only in ground frame. So only real forces will act on it. So I draw the separate free bodies of 2m and 4m with respect to ground. Okay. So this is like this. This is 2mg. This is equal to t. This is n2. Now I draw the free body of 4m. I draw the free body of 4m. Okay. This is 4mg weight. Ground exerts normal force N3 on the wedge. This is a pulley is fixed to the wedge. So this 2m exerts a normal force N2 on the wedge. Okay, fine. And this string, it passes over this pulley and it is in contact with this much portion of the pulley. This much portion of pulley this much portion of string is in contact with the pulley. Effectively, string will exert a force on this pulley at only this point and this point. That is somewhere here and somewhere here. T and T. Okay. What I am saying, I will repeat it. The string is in contact with this much portion of the pulley. This string is in contact with this much portion of the pulley. So this much portion of string exerts normal contact force on the pulley towards center of the pulley. If you take the resultant of these two, then we'll get effectively that string is exerting force on pulley only at 2 points effectively, at its topmost point and at this point. So T this side and T this side. This is a complete FBD of 4m. Okay. This is the FBD of 2m with respect to ground. Now while writing down combined equation, we only have to take the real forces, no external forces, no internal forces. Now here N2 is an internal force, it goes away. This T and this T, they are also internal forces, they go away. So what are the external forces? External forces are only external forces are this 4mg, N3, 2mg. These are only external forces. And this T, this T is also an external force. Alright, so external forces on the block wedge system are 4mg, 2mg and this T. And remaining all are internal forces. Only external forces are this and this. But we are writing down the combined equation in leftward direction with respect to ground. So only this real force comes. These two do not have any component because they are right angles to leftward direction. So only T comes. So T. Okay, fine. Alright. This becomes T is equal to how much? 4mb. 4mb. Alright, fine. See, 4mb, alright. Now, we write down the term here. Here what we have to write first of all, mass of 2m into what? Component of acceleration of P1 with respect to ground in this direction. So let's label this direction as x-axis. So I write down the name of the term here. What I'll say? A P1G X component. Okay, fine, alright. Now I write here. So what do we get? T is equal to 4mb plus 2m into A P1G X component of acceleration of block P1 with respect to ground, where X direction is leftward direction. X direction is nothing but leftward direction. Alright, fine. So this becomes T is equal to 4mb plus 2m times A P1Gx. Okay. Now we'll write it further, we'll simplify this term. Achha, what will you get this term? I'm telling you in advance. This term will be simply be equal to b minus c cos 60 degree. B minus c by 2. But I'll prove it here separately, okay? T becomes how much? 4mb plus 2m. On this I write is as a dot product. A P1G dot what? I hat. Alright. T is equal to 4mb. What is I hat? I hat is unit vector along x-axis, leftward direction. Plus 2m. Now A P1G, that I'll write as translating frame formula, I'll write that as A P1W plus AWG dot I hat. Okay, fine. Alright. Now I rub this one. This I rub, okay. So what do we get here? T is equal to 4mb plus 2m. Now what is AP1W? That is vector C. Plus AWG, that is vector B. Dot I hat. So T becomes 4mb. We apply distributive law of dot product. C dot I hat plus B dot I hat. T is equal to 4mb. What about C dot I hat? C is this way, I hat is this, angle is 120 degree. So by rule of dot product it becomes C into 1 into cos 120 degree. And you minus C by 2. And B dot I hat, that becomes B into 1 into cos 0 degree, that is simply B. Alright, fine. This one I rub it, okay. So what do we get? T is equal to 4mb minus mc, 2 goes away, plus 2mb. T is equal to 6mb minus mc. This is the third equation. Okay, fine. So now what I'll write all these equations at one place, just to get more space for calculation. Okay. Now rub that one. Okay. So first equation is this. Second equation is this. Second equation is I'll write it here. mg root 3 plus mb minus t 2mc. This is the second equation. And this is the third equation. T is equal to 6mb minus mc. 6mb minus mc. This is the third equation. Now let us count the number of unknowns. Let us count the number of unknowns. How many unknowns are there? A, B, C and T. 4 unknowns are there. So we need 4 equations to solve them. See, N2, N1 they do not come into picture. So we don't take it into account. Okay. So we need 4 equations. So one more equation I'll write down. That equation will come from constraint relation. And what is that constraint relation? Length of string is constant. Sum of T dot A of all the blocks is 0. Okay. Now to demonstrate the essential concepts, I will write down the constraint equation first in ground frame and then in wedge frame. Okay. I will write down the constraint relation in the ground frame. Okay. Constraint relation in ground frame. Constraint relation in ground frame. Now, when we write down the ground frame, then that work done by string on all bodies in contact with it is 0. Okay. Suppose this block undergoes a displacement of say dx1 with respect to ground. Okay. this wedge undergoes the leftward displacement of dx2 with respect to ground, okay? And suppose 2m undergoes the displacement of dx3 with respect to the wedge. Now string is acting at how many points? String is acting at this point. This pulley is have no use. See, the string directly goes over that side. So you're just touching the pulley, so there's no effect here. So string is acting at this point force. It is acting on this pulley at these 2 points effectively, and this block at this point. Okay. So work done by tension on all these points adds up to 0. Now using in ground frame. Now T acts in this way, in undergoes a displacement dx1 in ground frame this way. So work done by T on this block will be T dx1 cos 0 degree. See, when we are acting on the constraint equation in ground frame, all the displacements have to be taken with respect to ground frame. Alright, so T dx1, okay. Here we don't have to consider anything, just touching the pulley. So there is no question about that at all, just touches it, glances it, okay. Now we take this pulley here. At this point T is acting in this way, and this point is being displaced by dx2, same as displacement of wedge with respect to ground, dx2 left. So T this way, dx2 also this way, plus T dx2. Now what about this point? At this point T is acting in this way, and this point is being displaced in leftward direction dx2. So angle between these two will be 120 degree. So T dx2 cos 120 degree. T dx2 into minus half. Alright, fine. Alright. Now take this one. Plus, now we need T acts on this block in this direction. And we need to know the displacement of this block in ground frame, because constraint relation is being written in ground frame. So what do we write? T dot displacement of this block P1 with respect to ground, say dl. That is adds up to 0. Okay, fine. Now this becomes how much? So this becomes T dx1 plus T dx2 minus T by 2 dx2. Now how do we write this term as? This becomes T dot. What is this dl? Displacement of P1 with respect to ground. Now for that displacement will be written as how? Displacement of block with respect to wedge, that is simply dx3, plus displacement of wedge with respect to ground, that is simply how much? Dx2. So adds up to how much? 0. Fine, alright. So this one I rub it here, okay? So now this becomes how much? T dx1 plus T dx2 minus T by 2 dx2, and we break this now. T dot dx3. T is in this way, dx3 is in this way. So T dot dx3 becomes how much? Minus T dx3. T dx3 cos 180 degree. And T dot dx2. T is in this way, dx2 is in this way. So this becomes how much? T dx2 cos 60 degree. This adds up to how much? 0. Now see this term, they go away. So all T cancels out. What do we get? dx1 plus dx2 minus dx3 is 0. So dx1 plus dx2 is equal to dx3. Now replace since there is no variable angle in the problem, we replace the displacements by the corresponding acceleration. Instead of dx1 we write A. Instead of dx2 we write B. Instead of dx3 we simply write C. So this is the required constraint relation C. This constraint relation we have derived in the ground frame, okay? So I'll write this equation here. A plus B equal to C. This is the fourth equation. Okay. Now just to demonstrate the concept involved, I will write down the constraint relation in wedge frame. That will again become much more easier. So constraint relation now I write in wedge frame. Again in wedge frame when we consider, then we have to take the work done by string on all the blocks on the bodies in wedge frame. So start from here. Now tension T acts on this in this direction, and we have to find the displacement of this block in wedge frame. Okay. So we write it like this: D dot displacement of first block dl1. What is dl1? Displacement of this block P2 with respect to wedge. Okay. At this point now, Now this point T acts this direction, and this pulley is rigidly fixed to wedge. With respect to wedge, this point has zero acceleration, so T into 0. Here also T into 0, because this point has zero acceleration with respect to wedge. So T dot this displacement will again be T into 0. Plus, see on this T acts in this way, and displacement of this block with respect to wedge is dx3 down the incline. So T in this way, dx3 that way, 180 degree angle. So it becomes T dx3 cos 180 degree minus 1. That adds up to how much? 0. Now T dot dl1. What is dl1? Displacement of block P2 with respect to wedge. Okay. Now what do we write? See, displacement of block P2 with respect to ground is how much? dx1. That is same as displacement of block with respect to wedge, which is simply dl1, plus displacement of wedge with respect to ground, that is what? dx2. So dl1 becomes what? dx1 minus what? dx2. This is what dl1 becomes. Now substitute this dl1 here. So T dot dx1 minus dx2, this becomes 0, minus T dx3 is 0. Now T dot dx1 is how much? T in this way, dx1 also in that way. So T dx1 cos becomes T dx1 cos 0 degree. That is T dx1. What about T dot dx2? dx2 is in this way. T dot dx2, T dot dx2. T dot, which one I am writing? Okay. T dot dl1, okay. Minus T dot dx2. So T is in this way, dx2 is in this way. This T, this one, dl1, dx1 is dx2. T is on this block we are taking. We are taking on this block, no? This we are taking on this one. This block, yes, T is in this way. And dx1 also is in this way, so T dx1. And T dot dx2, T is in this way, dx2 is in this way. Minus T dot dx2. So T dx2 cos 180 degree minus 1 more. Minus dx3 is equal to 0. Okay. Now T cancels out, you can see it. So when you cancel T, what do we get? We get dx1 plus dx2 minus dx3 is 0. Okay. So what do we get? dx1 plus dx2 is equal to dx3. Same relation which you obtained here. That means a plus b is equal to c. A plus b is just equal to how much? C. Same equation which you obtained by first method also. So in this way I have demonstrated how to write down the constraint equation in different frames of reference. So again you can see setting up the constraint relation wedge frame is much more easier as compared to that setting in ground frame. Calculation is greatly simplified. This is the advantage of constraint theory. Okay, fine. Now what we have to do is we have to simply solve this for t. That's all. I'll drop this one, okay? Now we have to solve for t. So from this a will become t by m, and from this b becomes what? B can also be solved in terms of c. Okay. So a plus b equal to c. We have to solve this equation now. Fine. All right. So what we have to do? If we add these two equations, second and third equation, if we add up, see a becomes t by m. B we get from this way, B and C we have to solve, okay? Alright. So we eliminate t from these two equations. We add second plus third equation we add. When we add these two equations, then t will go away. What do we get? mg root 3 plus mb. T goes away. Barabar 6mb plus mc. Second and third equation when we add, this is what we get. Alright. So how much do we get? How much do we get? mg root 3 plus mb is equal to 6mb minus mc plus 2mc. Okay. So mm goes away in this. So what do we get? We get g root 3 plus b equal to 6b plus c. G root 3 equal to 5B plus C. Okay, fine, alright. So, now what I do, I substitute this value of C in this equation. A becomes C, A becomes T by M. Now B becomes B in terms of C we have obtained. Okay. So from this I substitute this C in this equation. This C I substitute this. From this equation we see that C is how much? G root 3 minus 5B. This is C. This C I substitute in third equation. 6MB minus M. What about C? G root 3 minus 5B. Okay. So how much B becomes? B becomes T plus mg root 3 by 11m. This is what B becomes. C. T plus mg root 3 by how much? 11m. Okay, this is B. Okay. And C is how much? C is also we have obtained. I substitute this here in this equation. So I substitute this here. So A becomes how much? T by M plus B. B is this much. B is this. I substitute B here. So just write it at B itself. And C is what? From this C is what? G root 3 minus 5B. Okay, fine. So what do we get? 6B plus T by M is equal to G root 3. Now this B I substitute here. Okay. So when I substitute this here, what do we get? B I substitute in this 6B. So 6 times T plus mg root 3 by 11m plus T by M barabar G root 3. Okay. Now this can be solved easily for T. So T I take common, T by M common. 1 plus 6 by 11. Alright. T by M 1 plus 6 by 11. That becomes what? G root 3 minus 6 and G root 3 by 11. 6 and G root 3 by 11m. mm will go away. Alright, fine. So, now I rub this one, okay? So what do we get here? Yes, we get T by M 1 plus 6 by 11 means 17 by 11. That is same as G root 3. G root 3 becomes common. 1 minus 6 by 11. So T becomes 11 mg root 3 by 17. 11 mg root 3 by 17 into 5 by 11. Now 11 goes away. So T becomes how much? 5 mg root 3 by 17 is therefore the required answer. Okay. So value of T becomes 5 mg root 3 by 17. This is therefore the required answer to the given question. Okay. So this also I have demonstrated in this problem. I have demonstrated. Okay. In coming video I will take up more problems on this type. Okay. So 3 to 4 videos or more I will make on this chapter, Newton's laws. Then I will pass over to friction. Okay. So just you go through it properly. If you have any doubt, you write down in the comment box. I will clarify all your doubts. Okay. So this I close it here. Fine.